we need to use source conversion method to find the current through 8 ohms resistance, the 8 ohms resistance here, and the power dissipated by this resistance. So basically, if we can get the current, if we know the current, we know the power, that I square R, and we have the R, so that's fine. We need to find the current first. So we have to use source conversion technique. So what I will do here, source conversion means I will briefly talk about the theory here. So basically, if we have a current source I and a with a parallel resistance, it can be converted into a voltage source and a series resistance, and the series resistance stays the same. The current source, the voltage source value becomes like this: V will be I times R basically. And similarly, if we have a voltage source with a series resistance, that can be converted into a current source with a parallel resistance, where the resistance value will be the same, but the current value will be I over R. I will be V over R. So if we wanted to convert from here to here, we would get V over R, so that would be just this I. So that's there. So what I will do, I will first convert this into a voltage source and a current a series resistance, so that will become and like this, and then our 8 ohms, which we will have to keep intact. So this is 8 ohms, and this will be 10 ohms there, fine, and we will have 30 volts, because 3 amps and 10 ohms multiplied by 10 ohms multiplied by 3 amps will be 30 volts. And here what we will do, we will first convert this one into a current source and a parallel resistance, sorry. We have to, I will do in the same diagram. So it will become like this, and this will, the polarity will be as such, so the current is in the same direction, of course. So this will be, since the polarity has a plus and minus here, the current source direction will be also upwards. So the value of the current source will be 15 volts divided by 3 ohms, so that will be 5 amps, and this will be 3 ohms, and this will remain 6 ohms. So that's like that. We won't have to do anything here. This will remain 30 volts. This is 10 ohms, and our 8 ohms will of course remain intact. So 10 ohms. And then here what we will do, we will try to write the parallel equivalent of that. So 6 ohms and 3 ohms parallel will be 6 times 3 divided by 6 plus 3. So that's 2 ohms. And then current will be like that, the same 5 amps, whatever was there. And now we will convert this one again into a voltage source and a series resistance. So this will become, so that's 8 ohms, that's 10 ohms, and this one is 30 volts, and here it will become 5 amps times 2 ohms, so 10 volts, and then 2 ohms in series, so like that. So 10 volts, 10 volt and 2 ohms there. So now we know the current direction will be, since this is plus minus here and this is plus minus here, the current direction ultimately will be in that direction, because 30 volts is higher. So this is 10 volts. So I, if we say the current is, there will be just one current because it's a series circuit. So current through 8 ohms will be just that I, if we say it I, so that will be 30 minus 10 divided by 10 plus 8 plus 2, so that will be 20. So 20 divided by 20, so that's 1 amps. That will be the current through 8 ohms resistance, and power will be, of course, I square R. So 1 times 8, that will be 8 watt. So that will be the power. So the circuit becomes, this is a typical circuit that is ideal to solve using the source conversion method. So